The story that we are going to discuss today is one that is over 500 million years old in its age. It's a story about a violent tectonic collision that produced a slew of positive and negative events. It built the landmass of eastern Victoria and raised it from the deep ocean, but it also led to the formation of extremely powerful volcanoes, accompanied, of course, by massive earthquakes and a tsunami risk. But it also deposited vast mineral wealth. That's right, this is also a story about treasure. These same destructive events released a slew of metalliferous wealth, a byproduct of the voluminous amount of magma that would upwell towards the surface during tectonic collisions. Valuable riches in the form of gold, silver, copper, and more lie in wait, stored in huge reserves, just waiting to be tapped into and found. But these riches were hidden so well, we never even knew they existed until very recently, when their existence finally came to light with the help of modern technology, which shed light on the existence of an ancient volcanic arc that still exists in present day, known as the Stavely Arc. And it's literally lying in an area that is now the relatively flat inland region of Western Victoria. This ancient arc was hidden beneath hundreds of meters worth of sedimentary material that had accumulated and buried it over many tens of millions of years. There are some places where the material associated with these ancient explosive volcanoes are exposed in present day, but these places remain few and far between, only further adding to the mystery that had stumped Australian geologists for decades, all the way back to the days of the gold rushes in the 1850s, when geologists were everywhere and mining was an incredibly important part of everyday life. But now technology allows us to peer beneath the surface, and this is what this video is all about. This is the story of Australia's brand new mineral rush, and the massive tectonic and volcanic origin that produced it. Gold, silver, copper, lead, these are just a few of the metals that lie in massive, and I mean massive quantities, and they are just beneath the earth, right now, just waiting to be found and extracted.
Volcanic arcs are associated with some of the most violent and powerful volcanic eruptions on Earth. The volcanoes that develop here are either your typical conical formation, known as a stratovolcano, which releases eruptions that are incredibly dangerous to be around, or they can go one or more steps higher in their level of power, creating an eruption so strong it blows a stratovolcano apart and then collapses it to form gigantic calderas during the volcanic eruption, with some of these volcanic complexes being so powerful that they erupt at a supervolcanic scale, forming a caldera so large you most likely wouldn't even know you're in a caldera. Either version of these volcanoes can be so powerful that they can totally bury entire cities beneath tens to hundreds of meters worth of material in a mere matter of minutes, when they release giant pyroclastic flows or trigger violent lahars. These volcanoes are also associated with the formation of tsunami waves, occurring usually when a volcanic landslide occurs, or if the volcano is located near a large body of water during a caldera collapse. So when these arcs are active, it's a pretty turbulent area to be near. Along with the volcanic risk, you also have to deal with extremely powerful and frequent earthquakes and subsequent tsunami risks. But along with this danger exists valuable riches just waiting to be found. These arcs are associated with the release of extremely precious metals, with gold, silver, lead, and copper being a few of the metals that occur en masse when these events occur. And these deposits usually accumulate for millions or tens of millions of years, leaving layer after layer of extremely metal-enriched deposits that would make you rich overnight. But in order to find these, you have to know the different ways that these valuable and much sought-after metals accumulate, and we will cover all of this later on.
A volcanic arc is also known as a magmatic arc, and this giant belt of volcanoes form above a tectonic plate when another plate collides and subsequently subducts beneath it.
Present-day examples of these types of volcanic arcs can be found within the Japanese archipelago, the Sunda Arc in Indonesia, or within the Andes. The volcanic arc we are going to cover today formed in exactly the same way as all of these examples, but it was more closely related to the Andes in the chemistry of its magma and in the topography of the land, meaning the place it occurred at more closely resembles the Andes in its biomes and overall layout, with gigantic mountain ranges stretching high into the sky, with hundreds of massive volcanoes and volcanic calderas dotted everywhere throughout the land. Victoria is located in the southeastern portion of Australia. It's known for containing some of the richest goldfields to exist on our planet, and the geology here is convoluted, layered, and beyond complicated. The massive sequence of effusive eruptions produced wave after wave of lava flows, and occurred at over 400 different locations all throughout the state, starting sometime around 2 million years ago, as Victoria drifted north over a hotspot that had been causing inland volcanic eruptions to occur in Australia since northern Queensland first drifted over it, and in time, the hotspot slowly moved south all the way to Victoria and beyond, lying somewhere beneath the Bering Strait in present day. The vast majority of the state is covered in basalt or is located beneath large amounts of sedimentary material, meaning vast amounts of wealth lie beneath the soil, but the only way to find and extract it is by understanding how this complicated geological puzzle that is Victoria formed, so that we can extrapolate this understanding towards deciphering what riches lie in wait to be discovered. The only issue is Victoria is unbelievably complex. Like really, it's an absolute mind. It's only recently that it's begun to be understood, purely because of modern day technology and the ability to measure deep within the Earth. As a result of this new ability, Victoria has some of the highest quality magnetic and gravity data available in the world from the recent and thorough in-depth studies that have taken place here. Magnetics allow us to peer down to about 30 kilometers beneath the surface of the Earth, and with gravity, you can see even deeper than this. And this data, combined with drill cores, can penetrate deep into the Earth to take a sample of the rocks and investigate what minerals make up the layers without having to physically investigate it by constructing a mine shaft like they would back in the old days, and this unlocks the ability to prospect on an entirely new scale. So these techniques, along with other recent technology, have finally begun to unravel the complicated puzzle that is Victoria, and that has led to some truly monumental discoveries. Take this gold mine for example. It was discovered in an area where gold was first discovered in 1894, and it was then mined until 1903. But the old miners, who were amazing at what they did by the way, completely missed this unbelievably gold-enriched location. But how? Well, it was located beneath basalt that was erupted from the more recent volcanic eruptions, and was only discovered using modern techniques. It was completely hidden from the miners, and they had no way of knowing it existed there. But at only 15 meters beneath the surface, underneath this basalt, lay a vein of quartz so gold enriched that it yields 1429 grams per ton, which is unbelievable. That means this mine earns 115,277 Australian dollars per tonne of ore crushed, and they've mined over 3.5 million ounces of gold since the commencement of the current operation in 2015. This is one example of what recent technology is allowing us to discover, and the next discovery might be a Fosterville times 1000 or more, because this isn't just one spot that's been discovered. It has unlocked the potential for an unbelievably vast amount of mineral wealth located underneath a vast stretch of land. And this is where our story drifts back to the magmatic arc. Victoria formed within the past 550 million years. It was originally just a deep ocean that lay off the east coast of Gondwana. Tectonic collision occurred as the ancient Paleo-Pacific tectonic plate collided with the continental plate of Gondwanaland, and the heavy oceanic Paleo-Pacific plate subducted beneath the lighter continental plate. This collision led to the formation of a gigantic volcanic arc, known today as the Stavely Arc. It stretched from the shores of ancient Gondwanaland, which is now in western Victoria, all the way south and into Antarctica, which at this point in time was connected to Victoria, so a good part of this volcanic arc is also located somewhere in present-day Antarctica too. This entire magmatic arc lay hidden from the naked eye, and was completely undetected as it sat buried beneath vast layers of sedimentary material which had buried it in the past 500 million years since it finally became extinct. But when you look at it through the magnetics, suddenly something amazing pops up. As you can see, this completely changes our ability to see things. Suddenly, the large stretch of sedimentary plains and desert have become invisible, and what we now see are the remains of the now dead volcanic arc that roared to life vigorously 511 million years ago, but that most likely originally began life around 522 million years ago. This volcanic arc has changed dramatically though. It looks nothing like it would have when it existed. There have been several tectonic events that occurred here post 500 million years ago, and these collisions have folded, buckled, warped, and moved the volcanic arc all over the place. The orogeny that caused this buckling is most likely what killed the volcanic system to begin with, by thickening the crust and choking off the ability for magma to easily rise. And the multiple orogenies that would occur would lead to 19 present-day belts that exist of both volcanic and intrusive rocks. But 500 million years ago, they would have existed as only 4 large volcanic belts, before becoming twisted and rotated along with the present-day marvel known as the Grampians. 440 million years ago, the deep ocean retreated eastwards, and mountains began to be built, raising another large portion of Victoria out of the deep ocean, and it was during this time that the Grampian strata was laid down, burying the rocks that made up the Stavely magmatic arc, before becoming tilted and folded 405 million years ago, in an event that also affected the much older rocks that made up the Stavely magmatic arc. After this event, this part of the Earth became so stable that it preserved the upper crustal levels of these 500 million year old rocks, leading to them existing in present day, rather than them having been exposed and eroded away. This is extremely unique and is quite a special occurrence. So the reason why this discovery of the Stavely Arc is so significant, among many other reasons, is because the Andes are known for having some of the richest copper porphyry deposits in the world. And along with that, the Andes also has vast quantities of other valuable metals such as gold. It is a place of immense tectonic activity in the form of earthquakes, and there exists some of the strongest and most explosive volcanoes along the entire Andean mountain range, from your standard Plinian volcano all the way up to supervolcanoes that are active in present day. So 500 million years ago, if you were to stand at this location and look out to the east, you would see nothing but a vast stretch of ocean that would be the Paleo-Pacific Ocean. And if you looked west, you would see massive rugged mountains similar to the Andes, only located in present-day Victoria. The one difference is that the Andes is tectonically active in present day, whereas this volcanic arc is long dead. This is huge because the most valuable phase of mineral injection is in the final pulses that are released by the magmatic system as it is about to die. This final burst of fluidic wealth deposits the largest and the most richest layer of gold, silver, copper, lead, tin, etc. The reason this occurs is because as subduction ends, it's changed from the arc being shortened and squashed to suddenly being released into extension again. The final release of this confining pressure results in a massive pulse of magmatism that brings metalliferous granite and porphyries towards the surface. So somewhere underneath the deserts and sedimentary plains of Australia lies an incredible amount of vast mineral wealth that might be worth billions upon billions of dollars or more in value. And these riches lay not only in the volcanic rock that was released, but also in a much wider stretch of land, with nearby sedimentary rocks from this date, 500 million years ago, also containing vast amounts of these riches. But how could sedimentary rocks contain them? And how do bursts of pure gold and other valuable metal deposits form? One way is within what is known as volcanic massive sulfide deposits, or VHMS deposits for short. These form directly on the seafloor in an area where ocean crust is being stretched away from the subduction zone. When highly active, these deposits can be associated with what is known as a black smoker environment, which are essentially chimneys located directly on the ocean floor that are constructed out of valuable metals that increasingly accumulate with time as more acidic fluid continues to upwell through the ocean crust. When the Paleo-Pacific Ocean was subducting beneath Australia, the section that was magmatic occurred mostly in the oceans near the continental land of Gondwana. It started deep within the ocean and released wave after wave of VHMS deposits during its life. Black smoker environments scatter precious metals all over the place, leading to them accumulating on nearby sedimentary material, where it would then become intertwined within it. So the area of land that could be enriched is vast beyond words, and these metals all tend to accumulate with other metals of the same type because of their varying specific gravity. So when one section is discovered, vast amounts of it lie in one area, making it easier to extract. But there's a second way that these valuable metals are deposited, and that occurs with a phenomenon known as porphyry deposits, which itself includes epithermal deposits. Porphyry deposits are the final burst that I mentioned earlier. They are intrusive deposits and they form at depths of 1 to 6 kilometers beneath the surface. As magma cools, metals begin to precipitate out of the highly pressurized and hot hydrothermal fluids, and they begin to enrich the nearby rocks around the magma chamber, creating what can only be described as a mineral-rich halo around a slowly cooling and solidifying magma chamber. As temperatures drop, metals begin to separate out one at a time, beginning with copper, followed by molybdenum and gold, then silver, lead, and zinc, creating zonations of enriched areas with different metals. As the magma chamber cools, the top of it crystallizes, resulting in the release of water and other volatiles. These hydrothermal fluids carry metals from the top and exterior of the magma chamber into the surrounding rocks as it exploits cracks and voids above it. As these metal-rich brines ascend and the pressure decreases, they eventually reach their boiling point, at which time metals begin to drop out of solution. Again, like before, copper comes first, followed by molybdenum and gold, then silver, lead, and zinc, as we get further away from the heat source. This process creates epithermal deposits above the magma chamber, which form in the cracks in the surrounding rock as veins and along weak sedimentary plains as sills, which can then be exposed due to erosion or can still remain preserved. In this case, they are preserved and they lay out there right now, hidden beneath the sedimentary basins of the Murray and Otway Basin. So this final porphyry phase occurred at the 500 million year mark, when this volcanic system released its final metal-rich pulse of metalliferous porphyry deposits and granites that intruded into the upturned fault slices of the dying Stavely Arc, with epithermal and VHMS deposits located across an incredible stretch of flat, ordinary, and deceivingly boring land, with sedimentary rocks also containing it, which only further increases the search radius, meaning there's not only a brand new gold rush that's about to occur at a modern day level in Victoria, but there's also a potential for a copper rush among other metals, with billions upon billions of dollars in rock form laying out there right now just waiting to be claimed. It's just been discovered, so it won't be long until the riches that are lying out there in wait are found and extracted. So in present day, the fault known as the Moistened Fault marks the line where the ancient continent of Gondwanaland met the subducting Paleo-Pacific tectonic plate, which is something that I find fascinating, and this is why I love geology. This entire story is just incredible in my eyes, and the riches it left behind to be claimed are just mind-blowing to me. It astonishes me to think that at this point 500 million years ago, to my west was the vast supercontinent of Gondwanaland, and to the east was a vast ocean that stretched out for hundreds to thousands of kilometers into the distance, and right at the edge of the continental plate lay a vast chain of explosive volcanoes that would lay down vast mineral wealth, and whose image still exists to be seen in present day with magnetics. This is the closest I can get to a stratovolcano in my home state, and I'll take it.
Thank you for watching. If you made it this far, consider sharing this video around. It really helps the channel out. If you're a fan of volcanism, geology, geography, earth science, or science in general, then consider subscribing to the channel and hitting the like button. I'll be releasing more content like this regularly. Leave a comment letting me know what you think about this video, and if you have any video suggestions, please do let me know. Thank you again, I'll see you all real soon.